Welcome back to the Federal Executive Forum on Federal News Network. We're talking about 5G, and we're just getting ready to talk about specific use cases. I'm going to ask you, Dwayne, to give us an example of a use case of where this capability is rolling out at the U.S. Air Force.
All right, great. Well, as we mentioned earlier, 5G is still at its very early stages, and most of the focus has been on the enhanced broadband capability, which is there already. And the really transformational aspects of 5G are the ones that are still coming, and that's the ability to connect to everything, the Internet of Things, as well as the extremely low latency, almost no delay. And I think where we see the kind of the closer range transformational opportunity I see in the commercial area is in factories, in terms of setting up a private network at a factory where you're able to capitalize on all aspects of that in a very secure environment. And if, for instance, we can see like Mercedes-Benz has already started this, where they can change the assembly line on the go. They have over 300 autonomous vehicles to bring in parts just when they need it. And then if with augmented reality glasses, the people on the floor can actually call up schematics and dashboards and do troubleshooting. Well, I see this similar type of application as we consider the flight line of the future. And we're looking at these use cases at Hickam, Joint Base Pearl Harbor, Hickam in Hawaii. And that's part of the DoD 5G test beds. And as I said, also we're trying to tap that into maybe in Tyndall Air Force Base. And so it's looking at how do we optimize the flight line and maintenance, especially if you can capture the data that's coming down from the aircraft, and the maintenance team has that ahead of time and able to bring the parts in time, use augmented reality to capture more data, as well as autonomous vehicles to bring the parts together and also control inventory, do preventive maintenance. There's so many different applications. So it's, again, this is where you see the real advantage of 5G. It's the ubiquitous nature of it, taking all these kind of disparate capabilities and bringing them all together and really having an impact on the mission.
Right, and that, again, that real super low latency, real-time capability all of a sudden unlocks all these use cases that are just incredible. Brian Wenger at Palo Alto Networks, you have you're in a unique situation like many of our partners, where you're seeing this sort of across the community. Give us one example of where you're seeing some early adoption of this capability, where you're able to sort of get in there and put this wrapper around it, if you will, that you described earlier in securing it.
Yeah, so Palo Alto, especially within our 5G team, we continue to have a joke that this is the first time in a lot of our careers that we've seen the government is actually leading the charge here. They're much further ahead than we've seen in a lot of the private sector industries, that they're adopting 5G much quicker. They seem to have a vision for the future that is a little bit more well-formed than we're seeing with some of the private sector organizations out there. So when we take a look at this, we're looking at sort of predominantly what's going on within the OTAs that the military and the Air Force has released to try to uncover their use cases. What Palo Alto kind of brings to bear there, and what our vision is and how we're partnering with them, is really based around this zero trust approach that's kind of taking off at a rapid pace within the government. Is we're looking at securing these environments, and we're looking at doing it in a way that adds to kind of zero trust. And when we think about what zero trust means, it's kind of all about contextual information driving the access for what the users or the equipment or massive IoT devices have within the 5G environments. And what that really means for us at Palo Alto is how can we grab contextual information that's relevant for 5G and apply access and apply rights and apply network functions and policies based off of that. So what we're really looking to do through some of the efforts with these OTAs, as well as some of the lab of excellence that NIST and NCCOE has developing, is how can we come up with policies and how can we grab the contextual information which is relevant to 5G, like subscriber IDs and network slice IDs, instead of relying on legacy technology like an IP address or a username. So we're really developing this zero trust approach, which is going to be specific to a 5G environment.
I like the idea of that, and that's again that convergence, which is very interesting and certainly very timely and much needed. Major General Easley, I apologize. I think I cited you as Major Easley before. We're going to promote you back to General with no ceremony. Give us an example, specific example of what's going on at the U.S. Army. I know it's early adoption time, but I know that you all are in the middle of doing some of these capabilities. Can you give us an example of a program that you're rolling this out?
Sure. We're just like Dwayne said, again, we're looking at a lot of different use cases. This year, we've got two that I would like to highlight. One is, how do we take the same technology and make it work in our command posts and our training centers? Again, a command post is this real conglomeration of systems that need to come together to create this operations center that we can go fight our wars from. Again, we've got our logistics pieces coming in there, our fire control pieces, our personnel pieces. All these kind of different systems have to come together in real time so the commander can see the situation awareness and they can make a decision and get those orders out to these systems. As we add more robotic systems in there, whether ground robotics or aerial systems, this kind of complicated network becomes even more complicated. So we see work at Fort Hood and at the National Training Center as some of those kind of key initiatives to be able to do that. But as we talked about from all these pieces, this doesn't come from free. There's a lot of work we have to do to make these different systems talk to each other. And we see a zero trust architecture as a way to do that. We know we've got to dynamically switch between a military provided network and a commercial network where we can. So when our soldier has a 5G endpoint, it's going to find the best route to be able to get that data, to be able to send that message through the system. So a lot of work that our network cross-functional team is doing, trying to figure out how to make that network of the future work for us.
Interesting catch there about rolling off the private network into the public network, we'll call it there, and stitching those two together and making sure that we all sort of follow this architecture that we're describing there. Again, good timing to have that available. Brian Shrumsky, how about at Verizon? Give us an example of a use case where you're rolling this capability out across the federal service.
Sure. So I'll stick on the military theme. One of the ones that we're very proud about, obviously we're participating in the OTAs and test beds, but I'll talk about real world use cases in our work at Miramar right now with Lieutenant Colonel Brandon Newell, where there's actually a commercial network deployed on the base. It's the first 5G millimeter wave network in the military from a commercial standpoint, where they're actually having a living lab. They're actually doing active testing, as Dwayne mentioned, on flight lines, where they actually have autonomous vehicles shuttling men and women around the flight lines on an autonomous shuttle. There's an autonomous flatbed that's actually transporting autonomous drones. So you get a double there. And then they're also looking to use both the 5G and 4G network to do different things around base perimeter security. They're actually doing a lot of work on smart energy. They actually have a solar array there. They're actually using wireless connectivity to actually power that. But I think the beauty of that is it's a commercial network, and they're actually using what Brian mentioned in security and all those things over a commercial network. Obviously, we're actively participating. We can build private 4G and 5G networks, but this is a real world deployment. This is not a test or experiment. They are doing testing experiment, but this is a fully functional world-class commercial network on a military installation in a highly congested. I think one of the things that I have a huge appreciation for the military in logistics is actually deploying a commercial network or a private network over a military installation and all the work that actually needs to do that, right? You have to coordinate with the FAA, right? And you're right outside of San Diego. This is not a remote facility. This is an urban environment. So all of that coordination with Verizon, working with the base leadership to do that is no easy feat. And they're taking advantage of that today of actually deploying and testing 5G services on a commercial network.
Undoubtedly, these bases are many cities, right? So there's a lot of complexity to that, and a fantastic example of real world example of 5G rolling out and being operationalized. So fantastic to hear that. Dan, how about at CISA? You again have cited sort of this this coordinated effort that coordination effort that CISA plays. Give us an example, if you could, of where that's sort of coming into action in real time these days.
Sure. Thank you, Luke. So CISA doesn't have one use case 5G installation or use case that I can profile.
Of course.
What it does have, as you mentioned, is collaborative activities and partnerships with other federal agencies. We're collaborative in our discussions with DoD. Right now, we're looking at assessing the interoperability of networks for hardware and software for 5G. We'll look at the interoperability of 5G mobile devices, and we're also going to look at testing for and then closing the vulnerability to virtual networks within 5G. And then we're also going to look at autonomous vehicles operating using 5G capability. We're leveraging the new and existing use cases within the federal government to determine the risk landscape. We're not just looking in the federal government, we're also looking at what other organizations are doing in their 5G deployments, international partners, and what industry is doing. The Prague conference last year, and there will be another one at the end of this year. Great example of where our international partners come together and talk about some of their use cases. And we exchange the information and garner the lessons that we can, that they've learned, and then the same holds true. We share our information with our partners so that we can give them the risk mitigation. They can develop their risk mitigation for 5G deployments. We also do that through individual international engagements with specific countries. So we take the information from one stakeholder, the lessons learned, the best practices, the challenges. We validate that information, we analyze it, and we share it with other stakeholders so they can benefit from the secure 5G successes. And this is government to government, government to industry, and industry to government as well. We've partnered with the Federal Mobility Group to look at everything, how we evaluate 5G security, asking and answering the question, how secure is my 5G network? How do I know it is secure enough to carry out the mission? DHS also has a Critical Infrastructure Resiliency Institute. They have a computer program which looks at 5G infrastructure laydowns in various cities. Up until this point, they've been moving the 5G hardware around within a city to find optimization. And now we're connecting them with a real 5G bed down in Washington, D.C. to see if the efficiencies can be found within the city itself, rather than creating a simulated city and a simulated 5G bed down. So we're moving forward with learning those lessons as well. We've also partnered with the Federal Enterprise Mobility Security Group to look at application programming, interface APIs for traffic intelligence, fortifying federal mobility security networks, and then also detecting 5G-based drones. Through our partnerships with NSA and ODNI and participation in the Enduring Security Framework, we published a report on the potential threat vectors to the 5G infrastructure as it is now within government. It brings together the threats seen in the US government 5G activities and includes that cohesive, that coherent answer that the other federal agencies are looking for as well. The next step for that group is to develop a follow-on report to highlight successful mitigations to those 5G threats. We put a lot of analysis, a lot of thought, and if required, some policy changes in place to then mitigate the risk once the information is shared and analyzed. The federal government can't do it alone. We can establish security standards, we can put policies in place, but it'll take all the stakeholders to make a secure and resilient 5G capability.
It takes the entire community to bring it all together, and such a critical role at the emerging technology phase, the early rollout, the early adoption, to have that coordinated effort in place. So we certainly appreciate everything that CISA is doing. Brian Kennedy, how about at CommScope? Can you give us a specific example of where you're seeing this capability rolling out?
Sure. Again, we're involved in a lot of the OTAs and test beds as well from an infrastructure perspective. I think when one specific application that comes to mind is we have a CRAN, a digital CRAN antenna system that we're able to leverage within shipboard applications to ensure that the 5G signal can be propagated through the ship, and that the folks on board can leverage their tablets and their phones while they're out at sea, as well as when they come back connecting to the terrestrial network. So that's one example. We also stay ahead on this connectivity perspective relative to C-band antennas. For instance, the development we're already beginning to ship antennas in preparation for the rollout of that. And we try to make sure we stay ahead with the connectivity. Fiber optic is another key area. We're seeing a lot of rich fiber backbone that has to go in to support, again, the 5G rollouts. But that's one specific one that comes to mind. We've got several other applications for private networks that we have as well that are being used, obviously, as the folks have already mentioned, switching from private back to public networks. It's just interesting transition times we're in, and we're certainly happy to be a part of it.
Great use case there on this fantastic technology. Well, let's roll over to some lessons learned. I know it's early adoption, but even in early adoption, all of you right at the forefront here of enabling this capability, there's always things that get discovered, things that others that are going to follow behind you should be considering. General Easley, let's start with you and give us some lessons learned of the types of things that you're thinking about there.
Sure. One of the key pieces for a 5G rollout is really taking a system engineering approach. Understand those use cases, understand the architecture, understanding your data standards. What data are you pushing between those systems? But one thing we haven't talked about quite yet is cloud. How are you going to get data off of these endpoints, moved into a cloud environment back? In the Army, we're rolling out what our internal cloud environment called C-Army. And that's what we see is kind of that key leverage is how do we get data straight from a 5G endpoint through the transport layer, again, either using commercial transport or our own private transport into our cloud environment to make analytical decisions there and then get those decisions pushed back to the edge. So that's how to replicate that and make that work over 50 different use cases is what we in the Army are planning to do over the next decade.
Fantastic. Dwayne, how about lessons learned from your perspective? What would you like to impart as far as wisdom on the community in regards to early adoption?
Right. I think actually this has been a great a model for the services working together and coordinating and communicating across organizations, and even with CISA as well. I'm part of the mobility federal mobility group. And we have a couple hundred people on that all across government. And so what I see what 5G is doing is it's really drawing within DoD all the different components together, and it's also drawing government all together, and it's drawing industry together. So I think we've never had something that has challenged our cultures to come together in such a way. Even I think of what 5G does. We're really combining the IT, information technology with OT, operational technology, and then with the defense industry. And these industries have really operated as separate cultures and separate security kind of protocols and all. And 5G is forcing all of us to come together in very unique ways that I think is very healthy and has a huge benefit, much broader than just 5G itself.
Coordination, very key to this whole aspect. Well, we're going to take another quick break and we'll be right back. You're listening to the Federal Executive Forum on Federal News Network.